Hello everyone. The title of this video is Write the equation of a circle in standard form. Every exercise I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and it's in the Intermediate Algebra 2nd edition text. I'm in section 11.1 titled Distance and Midpoint Formulas and Circles, and I'm under the heading Write the equation of a circle in standard form. I'm only going to be doing the even numbered exercises, right, the exercises that don't have a link to solutions, right, the odd numbered ones do. So I'll be doing 18, 20, 22, 24, 26, and 28 for this video. I will also have timestamps in the description of the video for each of these examples. Example 1's timestamp will start exercise 18, example 2 for exercise 20, example 3 for exercise 22, etc. I would also request that when I start a new problem, pause the video and try to work on it yourself first before watching me do it and then compare. Because if you're just watching me do these things and not practicing yourself, chances are you're not learning all that much. Okay, so we're asked in all the exercises in this video I'm going to be doing, we're going to be asked to write the standard form of the equation of the circle, right, given certain information. Alright, so let's start with number 18, which I have written out. So again, example 1, exercise 18. So first let's talk about this, what is the standard form of the equation of a circle? Alright, so before I even get into this problem, I'll pull up a new piece of paper and talk about that. Alright. So every circle looks like a D, sorry. Every circle is made up of points that are all the same distance away from a given point. Alright, this given point is called the center of the circle, and this distance that all the points on the circle are away from this given point, away from the center, that's called the radius of the circle. Okay, so here's the coordinate. Let's say we're on the coordinate plane and say this point is the center, and let's give it some coordinates. It has an x coordinate and a y coordinate. Now in this particular text, in most texts that you come across, the x coordinate of the center will be labeled by h, comma, and then the y coordinate of the center will be labeled k. Alright, now let me actually draw a circle around this. Alright, now again, this isn't perfect. I'm just doing a little hand-drawn circle here. I don't have a compass on me. Just trying to eyeball a circle around this center. Alright, that's decent. It's not great, but it's okay. Alright, so if you were to take any point, this point here, this point here, this point here, this point here. It doesn't matter. So let's say this represents any point on the circle. And it'll have an x-coordinate, that's unknown, because it can change. It'll be a variable, x. It can change as you move around the circle. And the same thing for a y-coordinate. Say it's just y, a variable, because that'll change as I move around the circle. So we have two variable coordinates for this point representing any point on the circle. The distance, right? The distance from any point on the circle to the center is this radius. Now the radius is usually represented by a lowercase r, right? So that distance is r, this distance is r, this distance is r, this distance is r, and so on, right? You take any point xy, go to the center hk, and that distance will be r. And therein lies the equation of a circle. Right, the distance from any point, x comma y on the circle to the center h comma k, right, is the radius r. Right. Notice I put is here. This is going to be an equal sign, an equation coming from this. So I'm hoping you remember. I'm not going to teach you again. I've done this in previous videos. I'm hoping you remember the distance formula. How do I express the distance from point xy to point hk, or from point hk to xy? All right, so this side of the equation is the square root of the change. Remember, it's the change in the x's squared, so the quantity x minus h squared plus the change in the y coordinates squared, right? So the quantity y minus k squared. And this distance between hk and xy is, right, is equals, and then the radius r. Okay. And then just to clean it up a bit, square both sides to get rid of this radical symbol. You square both sides of this equation, and we get the following. The quantity x minus h squared plus the quantity y minus k squared equals, and then squaring this side gives me r squared, the radius squared. All right, and I'm putting this in a box. This formula here, this equation, this is the standard form equation of a circle. Okay, where once again h is the x-coordinate of the center, k is the y-coordinate of the center, and r is the radius. And I'm just going to keep referring back to this throughout the problem, right? Throughout the video. So let's go back. Now that we know what the standard form of equation of a circle is, and I'll put it up top here, let's do number 1, which is example exercise 18 from the text. So radius is 9 units, right? Again, that's going to be little r. So that'll replace r in the equation. And the center is 0, 0, the origin. Right, so 0 is h, right? The x-coordinate of the center is h. The y-coordinate of the center is k. So h is 0, k is 0. And I'm just replacing all that stuff in the formula. So the equation in standard form of the circle they're describing with a center at 0, 0 and a radius of 9 is the following. X minus 0 squared, right, h was 0, plus y minus 0 squared, right, again, k was 0, equals 9 squared, right, the radius squared. And then we simplify this. Now there's no need to write minus 0, right? X minus 0 is just x. So that's x squared plus y squared equals 9 squared is 81. And there we go. That is what they want. X squared plus y squared equals 81. All right, and then just to verify it, I'm going to go to a graphing calculator, a free online graphing calculator that I know I've used in previous videos at a website called Desmos.com. And I'm going to just enter that equation that we got. Right, we got x squared plus y squared equals 81. And look at this thing that popped up. Let me zoom it out a bit. Look at this. Definitely a circle, right? And the center, hopefully it's obvious to you that the center of this circle is the origin. All right, and let me just I'll put the point 0, 0 up here for you to make it clearer maybe. Right? So the origin is labeled. Definitely in the middle of everything. And then look at all these points, right? All the points on the purple circle should be 9 units away from the origin. Look at this. This is 9, 0. That's definitely 9 units to the right. Here's 0, 9, 9 units above. Negative 9, 0, 9 units to the left. And 0, negative 9, 9 units below. And then, of course, you get all these other points, you know, 7.96, comma, negative 4.2. That should be 9 units away from the origin, right? Any point, all these points, all the way around, are 9 units away from the center. So, yeah, it looks good. Our equation seems correct. You know, it has a center at the origin, radius of 9. Next question. Right, so again, I'll have here's the standard form equation up again. And once again, this is a pretty simple one. You know, we're given the radius, so that's going to replace r, right? So the radius is the square root of 5. And you know, 0, 0 is again the center. So h is 0, k is 0. And I just substitute those into my formula. So the equation for this circle is, you know, the quantity x minus 0 squared plus the quantity y minus 0, right, k was 0, squared, equals, and then the square root of 5 squared, right, the radius squared on the other side. And then we simplify. Once again, you know, you don't need x minus 0 or y minus 0. That's just x and y. X squared plus y squared equals, and the square root of 5 squared just gets rid of the square root symbol. That's just 5. All right, and again, let me just double check this. I'll put this in the Desmos calculator. See that we get a circle with a center at the origin and a radius of the square root of 5, which is a little more than 2. Right? So I'm going to type in the equation we just ended up with, right? X squared plus y squared equals 5. And look at this, definitely centered at the origin. And look at this point here, 2.236. That's the square root of 5 rounded to 3 decimal places. That is the square root of 5 units to the right of the origin. Here's 0, positive 2.236, positive square root of 5. That's square root of 5 units above the origin. This is square root of 5 units to the left, this is square root of 5 units below, and then every other point, right, every other point should be about 2.236, right, 2.236, about the square, every other point should be the square root of 5 units away from the origin. Looks good. All right. Next question. So again, I'll keep the standard form equation of a circle up. And again, we're given a pretty easy problem here. We're given, in number 3, exercise 22 of the text, we're given the radius, which will be r, and we're given the center. So again, the x-coordinate of the center is h, the y-coordinate of the center is k. So the equation of a circle is the quantity x minus the x-coordinate of the center. So x minus -2, that quantity squared, plus another quantity with y minus the y-coordinate of the center, y minus 6 squared, equals the radius 10 squared. All right, and then we simplify. Now x minus -2, that's x plus 2, right? So this is the quantity x plus 2 squared, plus, and then y minus 6 is just y minus 6. So the quantity y minus 6 squared equals 10 squared is 100. And there we go. Again, I'm going to go back to the Desmos site and enter this equation and see if we get a nice looking circle with a center at -2, 6 and a radius of 10. Right, all the points on the circle are 10 units away from -2, 6. Alright, so the equation we ended up with was this: the quantity x plus 2 squared plus the quantity y minus 6 squared equals 100. Right. Alright, let me zoom out a bit so we get the whole circle in the picture. Let me put that center in, right? It was -2, 6. See how that green point's definitely showing up in the middle of all this. Right. And then some special points here. So this is -2, 6. See, -2, 16. So that's 10 units above. Here's -2, -4. That's 10 units below the center. Over here, we'd have 8, 6. That's 10 units to the right. Over here, we have -12, 6. That's 10 units to the left. And then, every other point should be 10 units away from the point -2, 6. Right? All these points. So looks good to me. Okay, next question. Right, it's all the same stuff in the beginning here. So number 4. Again, we're given the radius. Now the radius is 1.5. Right, that's r. The center, again, the x-coordinate we'll call h. The y-coordinate of the center we'll call k. And if I had the center and the radius, I can easily state the equation of the circle in standard form. So it's the quantity x minus the x-coordinate of the center. So x minus -5.5 squared, plus then another quantity with y minus the y-coordinate of the center, y minus -6.5 squared, equals the radius 1.5 squared. And then we'll simplify. X minus -5.5 I can write as x plus 5.5. So that quantity squared, plus, and then y minus negative 6.5 will be y plus 6.5, right, that quantity squared equals, and then 1.5 squared is 2.25, right? That's 3 halves squared 9/4, 2.25. And there we go. That's it. That's all we're asked to do. Write the equation of the circle with this radius and this center in standard form. And once again, we'll check it out. All right, let's look at it on the Desmos site. I'll enter the equation as I had it. It was x plus 5.5 squared plus and y plus 6.5 squared equals 2.25. All right, I'll move down so we can see the whole circle. Zoom in a bit maybe. Let me put the center in so you can see it. All right, the center was at negative 5.5 comma negative 6.5. Look at that. Definitely showing up in the center there, that black point. And all the points on the circle, all the points on this circle should be, 1.5 units away from the center. So look at these 2 points here, right? Negative 5.5 comma negative 5, that's 1.5 units above the center. And then this negative 5.5, negative 8, that's 1.5 units below the center. And every point on this circle, right, every point should be 1.5 units away from this center, and it looks good. Okay. All right, now the next question is where things start getting a little different. I will keep the standard form up, all right, so we can see it. But now, instead of giving us the center and the radius, right, they give us the center, right, so that's the HK, 6, negative 6, but then they give us another point on the circle, right? So this is not the, we don't know the radius yet, but the radius we can easily find. Remember, the radius is the distance from the center to any point on the circle. I've written this before. So r is going to be the distance between 6, negative 6 and this point on the circle, 2, negative 3. And we know how to do this, right? You should know how to find distance between 2 points. So the distance is the square root of, the change in the x-coordinates squared, right? So 6 minus 2 squared plus, and then the change in the y-coordinates squared, negative 6 minus negative 3 squared. So that'd be the square root of, 16, 4 squared, right? 16 plus, then negative 6 minus negative 3, that'd be plus 3. Negative 6 plus 3, that's negative 3, which when you square it is positive 9. That's the square root of 25, which is just 5. So the radius of this circle is 5 units, because we know the center and we know a point on the circle, right? The distance from the center to any point on the circle will be the radius. And now I have everything I need. Once you have the center and the radius, you can write the equation of the circle. So remember, it's the quantity x minus the x-coordinate of the center, right? X minus 6 squared plus y minus the y-coordinate of the center, y minus negative 6 squared equals the radius of the circle we now know is 5 squared. And then we simplify. There's x minus 6 squared plus, and then y minus negative 6 is y plus 6 squared equals, and then 5 squared is 25, right? And there we go. There's the equation of the circle they described in standard form. Alright, and again, I'll take a look at it on Desmos. So I'm entering the equation I ended up with at the end, with the quantity x minus 6 squared plus the quantity y plus 6 squared equals 25. And move the thing so you can see the whole circle. The center, right, was 6, negative 6. I'll plot that point so you can see it directly in the middle there. And they also told us, remember the point 2, negative 3 should be on this. So I'll plot the point 2, negative 3, and look at that. See, there it is there on this red circle. Center 6, negative 6, point on the circle 2, negative 3. And the distance between these 2 points is 5 units. And it should be that way for all the points, right? Every point, this point here. Here's, again, 6, negative 6. Here's 6, negative 1. That's 5 units above. Here, this is 5 units below. 5 units to the right. And all these points, every single one of them, including this, 2, negative 3 that we knew was on there, is 5 units away from the point 6, negative 6. Fantastic. Okay, and I've got just one more of these. It's the same kind of problem as number 5. Again, I'll leave the standard form up. So once again, I'm given the center, negative 5, 6, that's the h and k, but I don't have the radius. But I do know a point on the circle, right? It contains the point negative 2, 3. So the radius, right, the radius r is just the distance between these 2 points, right? The distance from the center to a point on the circle. So I calculate the distance between negative 5, 6 and negative 2, 3. So it's the square root of, remember the change in the x coordinates, negative 5 minus negative 2 squared, plus the change in the y coordinates, 6 minus 3, or 3 minus 6 squared. So this is square root. Now negative 5 minus negative 2, that'd be negative 5 plus 2, that'd be negative 3, but when you square it, it's 9. Plus, and then 6 minus 3 is also 3 squared is 9. And so we're getting the square root of 18 units, or 3 times the square root of 2 if you simplify that radical. But there's the radius. Right? The radius is the square root of 18, or 3 times the square root of 2 units long. That's how far every point on the circle is from the center. And now I have the center, I have the radius. I should be able to now write the equation of the circle in standard form. So remember, it's the quantity x minus the x coordinate of the center. So x minus negative 5 squared plus the quantity y minus the y coordinate of the center, right? Y minus 6 squared equals the radius squared, which is the square root of 18, or 3 times the square root of 2 squared. Right? And then simplifying, we get x plus 5 squared plus y minus 6 squared equals 18. Right? The square root of 18 squared would just be 18. And there we go. That is all we're asked for. Now, once again, I will take this to the Desmos calculator and check it out. So the equation we ended up with there was the quantity x plus 5 squared plus y minus 6 squared equals 18. Alright, and the center, let me plot the center again. The center was negative 5, 6, negative 5 comma 6. You see that's definitely in the center of everything. And they told us that the point negative 2, 3 was on this. And look at that. Right? I put the point negative 2, 3 up, and it's definitely on this purple circle. Right? And the distance between this point and the center is 3 times the square root of 2. Right? It's the square root of 18. It's 4 point something. Right? 4 point something. And look, so this point up here should be negative 5, 10 point something, right? 10.243. The square root of 18 is about 4.243. So, that's the square root of 18 units above, square root of 18 units below, and every point on the circle, every single one of these ordered pairs should be the square root of 18, or 3 times the square root of 2 units away from the point negative 5, 6. Looks good to me. Wonderful. Alright, and that does it. So again, please, I would definitely recommend, now you saw how it was developed, right, using the definition of a circle, but I would definitely recommend memorizing this, the standard form equation of a circle. X minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared, just to make things easier for you, quicker for you in the future. All right. And I hope that watching me go through these 6 examples helps you in some way, when you're asked to write the equation of a circle in standard form on your own. And thank you very much for watching.